How do electric vehicles work? Have you ever been interested in the science behind electric cars and how they work? What makes these environmentally friendly rides work? And how do they make it so smooth and quiet? Ready to learn how EVs work and why they'll be the way people get around in the future? Electric vehicles are a good way to avoid high gas prices or lessen the damage that gas-powered vehicles do to the environment because they are easy to drive and can speed up quickly. On average, they cost more upfront than gas cars, but there are a number of types that cost less than $40,000. There are also federal tax credits that can help, and the charging infrastructure is getting better all the time, which can help with range anxiety. But how do they work in real life? A gas-powered internal combustion engine car needs fuel to burn explosively in order to make energy, but an electric vehicle doesn't need that. Instead, the battery packs store electricity that is used to power the electric motor that are attached to the wheels and move the car forward. EVs have fewer moving parts than gas cars because of this, and they usually need less upkeep, no oil changes. A lot of different kinds of cars could be called EVs, from plug-in hybrids to fully battery-powered cars and even cars that run on hydrogen fuel cells. Hybrids use a small amount of energy, but they are still mostly thought of as gas-powered cars, albeit more fuel-efficient ones. This time, we'll only talk about how all-electric cars work, what the battery is made of. Every EV has a battery pack that is made up of groups of lithium-ion batteries, also called cells. The cells provide the power that the car needs to do everything, from moving around to running the air conditioning. Most of the time, it's at the bottom of the car between the wheels. To charge an electric car's battery works a lot like the lithium-ion battery in your phone, but on a much bigger scale. It draws power from the grid until it's fully charged after being plugged in or charged at a charging point. The number of kilowatt-hours that an EV's battery can hold tells you how much power it can store. More the number, the bigger the battery and farther you can drive that EV on a single charge. Each EV has a different battery size, and many types come in more than one size. The more expensive the car, the bigger the battery. One example is the 2024 Hyundai Kona Electric, which has a smaller battery for short trips, 48.6 kilowatt-hours or 197 miles of range, and a bigger battery, 64.8 kilowatt-hours or 260 miles of range. Big performance-oriented cars like the Rivian R1T pickup have batteries that can hold twice as much or more. Rivian has 3 different battery sizes: the normal pack, 105 kilowatt-hours, 270 miles range; the large pack, 321 miles range; and the max pack, 410 kilowatt-hours, 410 miles range. What's the difference between them? Things are already hard enough, but there are now 2 main kinds of EVs on the market. Most EVs made in the US used to have nickel cobalt manganese (NCM) batteries, which are very powerful and have a long range. In their base models, automakers have been slowly moving to a new type of battery called lithium iron phosphate (LFP). Lately, they are used by Tesla, Ford, and Rivian because they offer the same EPA estimated range for less money, no expensive cobalt and nickel. But LFP batteries lose power and range faster when it's cold outside. Because of this, NCM batteries are still generally seen as the better and more expensive choice, though some battery companies are working on more advanced LFP packs for future cars. In the end, both types of batteries work in pretty much the same way. They give off direct current DC power, which is different from the energy that comes from a normal wall outlet. That power needs to be changed into alternating current AC in order to make spinning force. That's where the way an EV's motor is made comes in. How the motor was made. The electric motor in an EV doesn't need to pressurize and ignite fuel to move the wheels. Electromagnets inside the motor, which are driven by the battery, make the rotational force instead. There are 2 groups of magnets inside the motor. One set is on the shaft that turns the wheels of the car, and the other is inside the box that holds the shaft. Both sets of magnets are charged in the same way, so they don't stick to each other. When the magnets push away from each other, they turn the shaft, which turns the wheels and moves the car forward. For the magnets to stay attracted to each other, their polarity has to change all the time as the shaft turns. If they didn't, they'd finally turn around to a point where they would lock themselves in place because they would attract each other instead of pushing each other away. This is done naturally by AC power, which is always switching between positive and negative. To keep the magnets from getting stuck, though, because the power from an EV's battery is DC, a gadget known as a converter is needed. The inverter in an EV quickly changes polarity about 60 times per second to keep the rotating force going. Other parts of the car, like the heating, entertainment, and lights that don't need alternating current, are powered by a separate DC converter. The driver can change the frequency of the current going to the motor. The direction changes more often as the frequency goes up. This makes more torque, which is spinning force, and the wheels spin faster. Except for Tesla, all EVs come with a level 1 cord that goes into the car on one end and into a regular wall outlet on the other. Tesla stopped including level 1 chargers in their cars in 2022. To get their EVs going, this is a great place to start while they decide if they need to add a level 2 charger for faster charging at home. Level 3 chargers can't be installed at home because they use a lot of power, more than what a home's electrical system can handle. People who like to take road trips can often find them along motorways. You can also find them in the city and around town. A lot of people use brands like EVgo, Electrify America, and Tesla's superchargers. All EV makers said last year that they would switch to Tesla's NACS charge ports starting in 2025. Car companies are making adapters so cars that aren't Teslas can charge at superchargers until then. EVs from Ford and Rivian can do that now. Next are EVs from Volvo, Polestar, and GM. Tesla has let non-Teslas use about 15,000 of its superchargers, but keep in mind that the company has said it will charge them more for the power. There doesn't seem to be a lot of availability in big towns either. How far can an electric vehicle go after being charged? The Lucid Air Grand Touring can go about 516 miles. Most EV owners worry about running out of power. Will an electric vehicle, EV, get the same gas usage as a gas-powered vehicle? There is no one right answer. At the time this was written, the U.S. Department of Energy said that the average range of an EV is 270 miles. But the ranges at the top and bottom are very different. The Mini Cooper EV has a range of 114 miles, though the next generation Mini Coupe may have a range of more, while the Lucid Air has a range of 516 miles. That range can be changed by a number of factors, both at the moment and over the vehicle's lifetime. Phoenix superchargers are used to charge the Tesla Model 3. When it comes to range, the size of an EV's battery is one of the most important facts. But no matter how much power an EV has, its range can be cut down by going on the highway all the time, speeding up and slowing down a lot, using fast charging, too much bad weather, and just getting older over time. More and more people are switching to electric cars every year as they get better and more affordable. The International Council on Clean Transportation says that in 2023, 9% of new cars sold in the US were electric vehicles. As of August 2023, they're up to 21% in some places, like Europe, and a huge 85% in Norway. However, the system for charging needs some work. For EV drivers, the best-case situation is charging at home and at work. This means that making a special trip to fill up the car is a thing of the past. Even though EVs still need to work out some bugs and won't stop climate change by themselves, they can be a part of a bigger movement to change the way we travel and make greener options. If you want to stay up to date with the latest in automotive technology and gain a deeper understanding of how electric vehicles operate, make sure to hit that subscribe button, share this video with friends, and leave a comment below.